The human eye is a highly complex and extremely efficient organ that gives us the ability to see. It is an optical instrument that collects and focuses light in order to produce an image. Our eyes are incredibly sensitive to light and contain two types of photoreceptors, rods and cones, that work together to give us the sharp vision that we are used to. Rods are responsible for vision in dim light and cones provide us with color vision and sharpness in brighter light. The cones in our eyes can distinguish up to 10 million different colors. The human eye is intricate, with many components that closely resemble the parts of a camera. Much like a camera lens cap, the cornea deflects the light entering the eye. The iris and pupil, like an aperture of a camera, control the quantity of light entering the eye. The eye lens too is like a camera, focusing the light to generate clear images. Nonetheless, the lens of the eye can become clouded with age, a condition known as cataracts. Fortunately, medical progress has made cataract surgery an effective solution. During the surgery, the clouded lens is taken out and substituted with an artificial synthetic implant, improving vision and clarity. The iris is the colored part of the eye, with its main purpose to control the amount of light entering the eye. Depending on the level of light, the iris will either contract the pupil to reduce the light entering the eye, or expand the pupil to allow more light to enter. This adjustment process takes some time. The retina of our eye has a large number of light-sensitive cells, containing two kinds of cells, rods and cones. Rods are specialized to detect the intensity of light, while cones are sensitive to the color of a particular object in our vision. Light is absorbed by the cells, processed and converted, then sent to the brain to form an image. Rods, also known as rod cells, are one of the two types of photoreceptor cells located in the retina of the eye. These cells are responsible for vision in low levels of light. In comparison, cone cells are more active in bright light. Rods allow humans to detect motion and to perceive shades of gray. They are also essential for night vision but are not capable of recognizing colors. Cones, likewise known as cone cells, are the other kinds of photoreceptor cells found in the retina. Cones enable us to identify colors and to detect color differences. They are more active in bright light and enable us to identify boundaries and edges. Accommodation is the process by which the eye adjusts the amount of refractive power necessary for focusing on an object for different distances. This adjustment is controlled by the muscles of the ciliary body, which modify the curvature of the lens in order to bring the image into focus on the retina. Depending on the species and situation, this process can be done either reflexively or consciously. It is essential to clear vision and is usually done unconsciously by most mammals, birds and reptiles, which can adjust their optical power by changing the shape of the elastic lens. Fish and amphibians use a similar process, but the distance between the rigid lens and the retina is changed by muscles. Myopia, referred to as nearsightedness or short-sightedness, is a condition in which light entering the eye does not focus directly on the retina but instead in front of it. This results in objects that are viewed from a distance to be blurry. Myopia can be corrected with the use of eyeglasses, contact lenses, or refractive surgery. A defect named myopia is pictured. Parallel rays of light from a far-off object are not focused directly on the retina, but instead in front of it. This results in the inability to see distant objects clearly. Myopia is fixed by wearing spectacles with concave lenses. When the concave lens is positioned in front of the myopic eye, the parallel rays of light appear to come from a more extended distance, thus improving the eye's capability to focus and see distant objects clearly. Hypermetropia, also known as hyperopia, is an eye defect caused by a low converging power of the eye lens or an eyeball that is too small. This results in far objects being seen more clearly than close objects. Additionally, astigmatism and anomalies of the eye muscle system can also cause hypermetropia. To correct refractive errors, glasses or contact lenses are used. For more severe cases of hypermetropia, corrective laser surgery is an effective way to treat it. Hypermetropia, also known as long sight, occurs when the image of a nearby object is formed behind the retina. This happens when the eye is too short or when the cornea or crystalline lens does not refract light strongly enough. People with hypermetropia may have blurred vision when looking at objects close to them, but clearer vision when viewing distant objects. To correct this vision problem, a convex or plus-powered lens should be used to bring the image forward and correctly focus it on the retina. Presbyopia is a phenomenon where changes in our eyes can make it difficult to focus on near objects as we age. The exact cause is not fully understood, but it is hypothesized to involve a loss of elasticity in the crystalline lens, changes in the curvature of the lens resulting from continual growth, and a loss of power in the ciliary muscles which are responsible for bending and straightening the lens. Fortunately, presbyopia is widespread and there are a variety of treatments available. Convex lenses in spectacles are the solution to correct astigmatism. These lenses are able to counteract refractive errors to improve vision, similarly to how it can be done to correct hypermetropia, just by wearing spectacles with convex lenses. Cataracts are a frequent source of reduced vision, and can happen to anyone regardless of age. The issue is that the lens of the eye becomes cloudy, hindering the light passing to the retina, thus reducing the sight. The most common way to treat this is an operation, which can effectively restoring the vision. Cataracts can be caused due to aging or other reasons, so it is essential to be conscious of the symptoms in order to get timely treatment. As we age, our vision can be impacted by the presence of cataracts. Cataracts are caused by the buildup of yellow-brown pigment in the lens of the eye, which slowly but surely reduces the amount of light that is able to pass through. This can lead to difficulty with tasks such as driving, reading, and recognizing faces, as well as the inability to appreciate colors and differences in contrast. Glare from bright lights can also be a major issue. Thankfully, surgery is available to correct this common age-related vision issue. Light scattering is when light is dispersed in a number of directions, and is an important element in both the human eye and cameras. In the eye, the cornea and lens assist in scattering light to the retina, whereas in cameras, lenses assist in scattering light to form an image on the film or sensor. Understanding how light scattering works is necessary for optics and photography. The sun's rays create a magnificent scene as they pass through a forest. The trees of the forest act as a filter, dividing the light and creating a vivid pattern of light and shadows. Through the partitioning and diffusion of the light, the eye is able to detect and catalog the details, like a camera would. Every intricate detail can be seen in this mesmerizing image, highlighting the complexity and accuracy of the eye. Light scattering is an essential component of vision. We can perceive objects as light is scattered and bounces off them. This scattering of light is a physical process that happens when light passes through a medium, for instance the air between an object and our eye. This phenomenon is the foundation of our capacity to see objects. A rainbow is a stunning sight to behold, formed when light is refracted and reflected in water droplets. With sunlight, it will appear in the area of sky that lies opposite the sun. For thousands of years, rainbows have moved people, showcasing the beauty and strength of nature. Light from the sun striking a raindrop is the start of the formation of a rainbow, an interesting process that can provide us with many valuable lessons. The light is reflected back while the remainder is refracted, splitting the white light into its individual colors. This refracted light leaves the raindrop and the colors disperse even further, resulting in the magnificent display of a rainbow. The night sky has long mesmerized observers of all ages. Its stars have been studied by scientists and philosophers, who have used their positions and twinkling patterns to uncover the secrets of the universe and of our place in it. By analyzing star positions and twinkling patterns, astronomers have been able to determine the orientation of the galaxy and measure the distances between stars. This knowledge has enabled us to gain a better understanding of the night sky and the remarkable beauty within it. The sky is often seen as blue due to a phenomenon known as Rayleigh scattering. Sunlight is made up of numerous different wavelengths that make up the visible spectrum. Gas molecules in the atmosphere more easily absorb the shorter wavelengths, such as blue, than the longer wavelengths like orange and red. This blue light is then scattered in all directions, allowing us to see it from all angles. The farther away from the horizon we look, the paler the sky will look. This is because the blue light is scattered further away and less of it is reaching our eyes. Cloud particles can have many different sizes, and this affects how they scatter light. Small particles, such as those found in smoke or fog, scatter all colors of light equally. This is why these types of clouds appear white. On the other hand, larger particles found in dust, pollen, and sand tend to scatter shorter wavelengths that our eyes see as blue. The light that is scattered when the beam of light interacts with the particles suspended in air is called multiple scattering, and this causes the light to appear white to the human eye. Multiple scattering is responsible for some of the amazing sunsets and sunrises we witness in nature. Seeing the world through the eyes of science, we can truly appreciate the beauty of nature and understand why the sky is blue. The light rays passing through more of the atmosphere at sunrise or sunset, when the sun is low on the horizon, causes more blue light to be scattered away, leaving the other colors such as red, orange and yellow unaffected. This results in the beautiful and majestic colors we observe at the start and end of each day. Thank you for your attention.